Hi, I want to take a few minutes to review the rules of right triangle trigonometry. And many mathematical cultures have discovered that when you have a triangle with one 90-degree angle, a right triangle, then there's one unique angle, and you can predict the ratio of the sides of the triangle based on that one unique angle. So in our conventions with trigonometry, we usually call that unique angle theta. And because a triangle has to have all angles add up to 180 degrees, if one of those angles is 90 degrees, then the other angle is forced to be 90 degrees minus theta. That's why I say one unique angle. Now the sides of a right triangle are named based off their proximity to the unique angle. The side that is next to the unique angle is the adjacent side. And adjacent means next to. The side that's across from the unique angle is called the opposite side, and the adjacent and opposite sides make up the 90-degree angle. And the third side is known as the hypotenuse. Now, if you're given an angle and you're given one side of your triangle, then there are a series of ratios that you could use to determine the other sides of that triangle. And these ratios are functions that have long been known, and every scientific calculator is equipped to calculate them with angles measured in either degrees or in radians. Now, the primary ratios are referred to as the sine, the cosine, and the tangent. So the sine of the angle is equal to the length of the opposite side divided by the length of the hypotenuse. The cosine of the angle is defined to be the length of the adjacent side divided by the length of the hypotenuse. And the tangent of the angle is equal to the length of the opposite side divided by the length of the adjacent side. Now, if you were to take these first two ratios and divide them, you'd have sine divided by cosine. Well, on the other side of the fraction, you'd have opposite divided by hypotenuse divided by adjacent divided by hypotenuse. That 1 over hypotenuse cancels out, and that gives you opposite over adjacent. So that means that the tangent of the angle is also the sine of the angle divided by the cosine of the angle. Now, there are three other ways that you could write the ratios. You could have the hypotenuse divided by the opposite side, and that is 1 over the sine of theta, and 1 over the sine of theta we call the cosecant of theta, usually abbreviated CSC theta. The hypotenuse divided by the adjacent side is 1 over the cosine of theta, and that's the secant of theta. And 1 over the tangent is the adjacent side divided by the opposite side, which we call the cotangent of the angle theta. Now, what these functions are a flipping of the ratio, not a way to undo the function itself. And if you happen to, instead of being given an angle and one side, be given two sides, you need to use inverse functions themselves to determine what the angle would be. So if you have any two sides of a right triangle, you can use the Pythagorean Theorem to figure out the length of that third side. The hypotenuse squared is the length of the opposite side squared plus the length of the adjacent side squared. So if you're solving for the opposite side squared, subtract the adjacent side from both sides, take the square root of both sides. Now to find the angle, if you know the opposite side and the adjacent side, you want to ask the mathematical question, what angle has a tangent with the ratio of that opposite divided by that adjacent side? And that function is mathematically called the arctangent, which is written as either the atan of our ratio of the opposite side divided by the adjacent side, or tan minus 1. This isn't 1 over the tangent, that's the cotangent. The cotangent is a ratio calculated from an angle. The inverse tangent, the arctangent, is an angle calculated by figuring out what ratio would, taken the tangent of that angle, be equal to that ratio. A little awkward, apologize for that. So for all of the functions, there is an arc function, an undoing function. So for the arc sine, what ratio of opposite side to hypotenuse lines up with the sine of that angle? So what angle would have a sine value that gives us the ratio inside our inverse function? So, just a key to remember, these, you get the angle gives you a ratio. With the inverse trig functions, you have the ratio, and you're using the ratio to find the angle. Thanks for watching.